How you doing, Kalia? Again, quick reminder for everyone who's just joining right now. Video on if you're not part of the video off request list, which is these 4 students over here. If you're not, just message me. Oh, thanks, Data. No worries. Yeah, it's just one of those things where I'm probably going to ask students to have their videos on again if you're not part of this list and you don't message me. And then after that, just start the do now. The do now might take a bit more than 4 minutes today. So hey, Marche. Hey, Jenny. I was just saying that the do now might take a bit more than 4 minutes today. So if you could get started on that as early as possible, that'd be great. Thanks, Kalia, for letting me know about your camera. Hi, Precious. Precious, you'll notice that you are one of the 4 students who has filled out the video off request form. So it's totally fine if you have your video off. For anyone who is not part of either this list, Steve, Precious, Kaylin, Habidat, please just message me if you currently can't have your video on. Awesome, looks like I'm getting my first few responses for the do now. So thank you to everyone who is completing that. And then if you have finished the do now, feel free to answer the morning wake-up question. The morning wake-up question is, if you had to delete all the 3 apps from your smartphone, which ones would you keep? Jordan asked how you're supposed to add a file to the Google form. I think you could either take a picture directly from there, or like there's either an option to like add a picture, or you can just like close well, wait, actually, let me think. I mean, you'd probably have to use your phone. I'm assuming that's what most of you guys have been doing. So I don't know, I was kind of envisioning you doing the work in your notebook and then taking a picture on your phone and submitting it to your phone. If that's like not possible for you right now, just let me know. But it's like basically the same process that we've done for like the rest of the exit tickets and things like that. So if you've been able to do the exit tickets, hopefully you were able to do the do now today. And I'm gonna give extra time again for everyone to do that. I'm gonna give longer than 4 minutes basically. Okay, thanks for letting me know, Emily. Yeah, if submitting a picture of the do now right now is gonna be an issue for you, I understand that, just because taking a picture and submitting like a file can be kind of a hassle. So just let me know in the chat if you aren't able to do that. And then that's fine. Just try to do the work in your notebook still. We're going to go over the do now right after this. So probably give 3 more minutes for the do now. Hey, thanks for letting me know, Jenny. I am getting responses for the do now, so thank you to everyone who is able to submit it. If you aren't, again, just work on the problem in your notebook, and then we're going to go over it in a second anyway. So yeah. Around 2 more minutes for the do now.
Mr. Wang, did you get mine? Because I don't know if it went through.
Sorry, could you say that again? Was that you, Clarissa?
Yeah, it was me.
Yeah, wait, sorry, is there an issue with yours? I see your do now. It looks good. I have a picture of yours. I have it pulled up right now.
All
Right, cool. Yeah, thanks for checking in. Okay, quick question for people who haven't submitted yet. If you're still working on it, would you be able to just type in chat that you're still working on it, or raise your hand actually, or like, yeah, just raise your hand in the, okay. Okay, sounds good. I'm gonna give a couple more minutes for people who are still working on it. Probably another 2 more minutes actually.
Mr. Wang.
Yeah. What's up?
I uploaded my do now how I usually upload notes. That's how I've been doing my exit ticket, so that's fine, right?
Yeah. If you uploaded it, like, did you upload it to Google Classroom or the Google form? Like either one of those? Okay, yeah, then it should be totally fine.
Okay, thanks.
Again, also generally for everyone, do nows, I generally won't be grading the do nows. I will grade 1 do now out of every week, just so I'm like kind of making sure that everyone is putting their best effort into it, and it will be like a random do now. But mostly I'm grading exit tickets and your class notes. So don't worry too much about the do nows. Okay, cool. So that's going to be enough time for now. Thank you for everyone who is able to complete the do now. I'm going to go over a few other points, and then we're going to go over the do now really quickly. I see some questions for people who weren't here yesterday. Today we're covering much of the same topic as we did yesterday, so you might be able to actually catch up today. Today would be a good day to catch up. If you are able to, I have a video recording of yesterday posted, also the annotated notes, so please take a look at that. And yeah, so we're going to go over the do now, so yeah. But besides that point, I'm going to cover the homework packet. So yesterday, I basically posted a video. I'm going to screen share that right now. Okay, so this is the Google Classroom. The first topic is, of course, today's topic. We're going to look at continuity algebraically. And then the second topic should be the review week and week 1 homework packet. And if you click this material that was posted yesterday, basically, here, I'll open that up on YouTube. Actually, I'll just show this over here. I basically like run through a homework packet, like example problems. Sorry, my internet's not very good right now, but yeah, I run through like problem by problem, like example problems that are extremely similar to the homework packet that I assigned. So you could probably literally set out the homework packet and work through it along with the video. A lot of the problems I just like replaced numbers or like changed the equation and then solved it. So I mean, it's like the exact same process. If you don't remember how to do a problem, you can literally consult the video. And I did manage to do the whole packet in half an hour, as you can see in the video. Obviously, I was doing it very quickly and like I should know how to do the problems, but again, that's just to enforce the idea that this homework packet should not take too long. So if you're having any issues with that, please message me. But yeah, just letting everyone know that this would be a great resource to do the homework packet, and I will be grading it for correctness. So please take a look at it. And it's either on the Google Classroom or in the email that I sent yesterday night, which everyone should have received. So homework packet video. Okay. Cool. So now I'm going to give everyone 1 minute to set up your notebooks if you haven't yet already. Today we're going to be discussing the same idea of continuity, but just looking at it algebraically. So basically yesterday we were looking at continuity and we did have a formal like definition, but mostly we were looking at just graphs, right? Like visually, what does continuity look like? And then determining from like the limit definition or the casual definition, whether it's continuous or not. Today, we're going to be looking only at equations and no graphs. So I'm going to give everyone 45 seconds just to set up their notebooks. Now, please begin if you haven't yet already. Okay, like 15 more seconds to set up your notebooks. Thank you to everyone who has their cameras on and are in frame. If you are not currently in frame, I'm going to ask you to do your best to have your faces in frame. And again, if you can't have your cameras on, I've seen the people who are messaging me about their cameras, so don't worry about that. But if you can't, just please message me. Okay, cool. So now we're going to move on to the do now that I asked everyone to do today. So the do now, I'm going to cold call on a few people just to help me fill out the table. So how about Mubarak, would you be able to come off of mute and share the X values that you put down in your table for the discontinuities on this graph?
X equals 3, X equals 1, and X equals -2.
Okay, would you be able to clarify the positive and negatives for those? Because you got the right numbers, but I would say the positive and negative values assigned to each of those numbers is not necessarily correct. So when you say X equals 3, are you talking about 3 or -3?
3, and then 2, X equals 2, and then X. Wait, no, X equals -3, X equals -2.
Okay. Gotcha. Yep, that's exactly right. So X equals -3, X equals -2, and then X equals, oh, actually, it's not -2. So it'd be X equals -3, X equals -1, and X equals 2. Awesome. Thank you for sharing that. Okay. I'm going to call on Tissier. Would you be able to go down this list and write down the type of discontinuity for -3, -1, and 2? Tissier, are you there right now?
You said me?
Yeah, would you be able to share your column
Okay,
for the
sure.
type of discontinuity? Okay.
I wasn't here yesterday. Hello?
Hello? Yeah, I wasn't quite able to hear you. I'm not sure if everyone else was, but could you share that again?
I said I wasn't here yesterday.
Oh yeah, you did message me that. Okay, no worries about that. Okay, thank you for that. Can I get Precious then? Would you be able to come off of mute?
Yeah. You said what?
Could you share what you filled in for this column right here for the type of discontinuity?
Okay. For X equals -3, it's gonna be what is it? It's gonna be a removable discontinuity, removable, and then for X equals -1, it's gonna be infinite, and then wait, no, for X -3 is gonna be a jump,
Awesome. Yep, it is a jump discontinuity.
and then X -1 is gonna be infinite.
Yep, awesome. And
then
the last one?
It's gonna be removable.
Awesome, great work. That is fantastic. Yeah, so just so people kind of remember visually, a jump discontinuity, I don't know how else to describe it. A jump discontinuity is when you can see the graph visually jump and then continues. we'll see that you can define these different discontinuities using the limit definition. If you're talking about the limit definition, the jump discontinuity is the one discontinuity. Well, it's not, how would I describe this? The main part that it fails with the limit definition of the continuity is that the two-sided limit does not exist, right? Because they go to different points. Whereas, for example, the removable discontinuity, the two-sided limit does exist. But actually, I am going too detailed into that. Okay, awesome. So, Marche, would you be able to go down the column for justification using limit notation and kind of express what you think for each of these, which might be a lot. So yeah, if you're able to do that, that'd be great.
So for the -3 is jump because -3 is going to be jump because like the limit on the left side is equal to the limit on the right side.
Awesome,
For number one, for -1 is going to be a vertical asymptote because it's an asymptote at -1, and then all right, and then 2 is going to be removable because the limit as it approaches 2 isn't equal to f of 2.
Awesome. Yeah, that's great. So I'm going to compare. I'm going to compare the answers for this at -3 and 2. So at -3 and 2, right? Well, at -3, the main issue is that the two-sided limit, the limit as x approaches -3, is different. I just covered that. For the removable discontinuity, so that's what defines a jump discontinuity, is the two-sided limit fails. Whereas a removable discontinuity, the two-sided limit is fine. So the limit as x approaches 2, that's great, it works. Whereas for -3, it does not exist. However, yeah, awesome. Thanks for sharing in the chat, Kalias. The issue is that the equation does not equal. So it doesn't meet this final requirement where it must equal f of 2. For this vertical asymptote, this second point, the part of the limit definition that it fails, again, I'll just write out the limit definition again. Well, the issue is that it's a vertical asymptote, right? So that means any point here is undefined. So the issue is that f of 1 is undefined. So it can't possibly equal the limit, right? Because this whole value is undefined. So how can it possibly equal anything? If a value is undefined, it can't possibly equal anything. So you could say that it also fails this because, again, f of 1 is undefined. So yeah, each of these fails the limit definition. And now we're going to move on to looking at how the limit definition applies algebraically. So I'm going to do this example problem really quick, and I would like for everyone to follow along. I'm going to give everyone maybe 20 seconds or so to copy down this first problem. Thanks for letting me know, Calista. So yeah, this first problem is the function of f of x, and then there's a piecewise function for when x is less than 2 and when x is greater than or equal to 2, and whether it's continuous at the point x equals 2. And then we're going to classify the discontinuity. Again, I will give maybe 20 more seconds, actually. Okay, awesome. So for these type of problems, and again with any continuity problem, I think it's helpful just to start off by writing out the end definition for continuity. So we have the limit as x approaches 2, right? This is just our definition for continuity that we learned yesterday. For f of x is equal to f of 2. So for a function to be continuous, again, if this is true, then the function is continuous. So you can take a few seconds to write that down if you want, but it's just the really basic idea we learned yesterday. So if a function meets this standard, if this all works, then it's continuous. If any part of it fails, then it is not continuous. It would be a discontinuity. So that's just our basic definition. We're going to write that out. Awesome. So now we have that written down. So again, this is just the basic definition that we learned yesterday. If this is true, then the function is continuous. But let's expand on this idea. So the limit of f of x as x approaches 2. What that really means is we're looking at the two-sided limit. So we're going to look at the limit. If the limit of f of x as x approaches 2 from the left is equal to the limit of f of x as x approaches 2 from the right is equal to f of 2. So if this works, then we have a continuous function. If it doesn't work, then it's discontinuous. And again, this is just an expanded version of the same definition, right? They're the same thing. It's just we're kind of making it more clear that we're looking at the two-sided limit to see if this limit first exists, and then evaluating again to see if our function can meet this standard. So they're identical, but just expanding upon that idea. Okay, so now I would like some participation in chat. So for the limit of f of x as x approaches 2 from the left, right? Which function would I input the 2 into? So I have this first function here and then a second function. Which function would I plug the 2 into if we're approaching from the left? I'm going to give 30 seconds for people to participate in chat. Thank you, Kalia. Thank you, Kata. Ashley, I saw you were raising your hand. If you want to share, you can come off mute. You don't have to, though.
Is it the first one?
Yeah, awesome. Thank you. Thank you, Ashley, for that. I see a couple more people participating in chat, so thank you for everyone who has sent their messages. And universally, everyone seems to think that is the first function, and that is absolutely correct. So remember, these are the domains, right? So this is where x of 2 is defined. So this is where x is defined. When x is less than 2, the function is 2x cubed minus 1. When x is more than 2, the function is 6x minus 3. So basically what we're looking at here, I'll just try to make this clear, is when x is equal to 2. Before 2, we have this first function. We have, I don't really know what this looks like, but I'm just going to draw a function. Let's say it looks like this. So this is function 1. And then after 2, when x is greater than or equal to 2, we have 6x minus 3. And I know at least that this is just some sort of line, right? So this would be the second function. Again, I'm not really sure if this is what the functions look like, but that's the idea of what we're looking at, right? And now we're approaching 2. We're approaching this point from the left, right? So approaching from the left. So you can tell we're going to be all the way, we're going to be curious about this first function. That's really what we're looking at. Since we're approaching from the left, we're going to be curious about this domain where it's x is less than 2. Sorry. Okay. You don't really have to draw these visuals again. Sometimes I just draw visuals on the side just to clarify things, but you don't have to do that. So I'm going to plug in 2 basically into this first function. So 2 times 2 cubed minus 1. And then from the second part, the limit of f of x is x approaches 2 from the right. I'm just going to fill in this idea. So obviously, it would be the second function now because we're pushing from the right. So you can see we're coming in from the right. So this entire time, we're very curious about this second function. Where does this function go to? So I'm going to plug in 2 from the right. It'd be 6 times 2 minus 3. And then we're just going to plug in f of 2. I would like some participation in chat now for f of 2. If we're just evaluating f of x at 2, are we going to use this first equation or the second equation? Thank you, Kalia. I'm going to give 30 seconds again. So for this final part, f of 2, are we going to be inputting 2 into the first equation or the second equation? 30 seconds for everyone, please. Awesome. I'm seeing a lot of the same answers. Cool. I'm getting a lot of the second equation. So thank you for everyone who is submitting your answers. And yes, you would be inputting 2 into the second equation. And again, that's because the 2 is, they specify that when x is greater than or equal to 2, we're going to plug 2 into the second equation. So the equal to is the symbol that we're focusing on. So we know that in the domain when x is equal to 2, we have to use this equation. We have to use 6x minus 3. Unfortunately, the 2x cubed minus 1, that's only for when x is less than 2, not equal to 2. So it's important to pay attention to these signs. So we're going to plug in to the same thing here. Now let's just evaluate. 2 cubed is 8, right? So it would be 2 times 8, which would be 16 minus 1, right? I'm just going to write this as 15 is equal to 6 times 2 is 12 minus 3 is 9 is equal to 6 times 2 minus 3 is equal to 9. And obviously, this does not work because the 15 and the 9 are not equal to each other. So we have a failure. It does not classify as the continuous point. And then where does it fail? It fails in that the limit as x approaches 2 from the left does not equal the limit as f of x approaches 2 from the right. So this is where it fails. This first point of the limit definition fails. So if we want to visualize that on a graph again, that means at 2, right? We have a certain function. Let's say it goes to here from the left, right? But from the right, it goes to a completely different point. So it might go to over here. And we know from this would be classified as a jump discontinuity. So that would also be our answer, a jump discontinuity. Because from the left and the right, they go to separate points. So I'm going to give everyone 30 seconds or so to copy this down.
Excuse me.
Yeah, go for it.
Can you go back to the other problems after you? Yeah, I gotta write down my notes.
Okay, yeah, I'm gonna show this for like other notes at the end of class.
Okay, thank you.
Thanks for asking. Okay, so hopefully everyone has enough time to copy this down. I am now going to give everyone 4 minutes to try to solve this second problem, and it's extremely similar to the first problem. Is the function f of x, and f of x is defined here, continuous at the point x equals 1? If not, classify the discontinuity. Using is looking at the domains, but it should be pretty simple actually. So x when x is equal to 1, that same everywhere else on the function is defined by this equation, x squared plus 3x plus 5. So that's how you can think about the domain. I'll scroll up a little bit. So actually, I can show this. But I'm going to give everyone 4 minutes starting now to write down the problem and solve it to the best of your ability. Please begin. It seems like I have like 1 or 2 people who are still copying down notes on the first, so I'm going to give 5 minutes actually, just so you can finish down copying that first part and also the second question. So at like 9:45, we're going to come back. And just once you get your answer for the second problem, just like whether it's continuous or not, please put your answer in the chat. And then I'm gonna cold call either on someone who puts it in chat or maybe someone just random in general. So please be working on the problem. Thank you, Favor, for submitting your answer. And a little bit less than 3 minutes left for everyone else. Again, please, after you get your answer, just message me if you get continuous or not continuous. around 2 minutes left, a little bit less than that. One minute left. Okay, so that is time. I understand, I think perhaps everyone needs like a few more minutes to work on this. I don't currently have time for that, but don't worry about it. I'm gonna call on a student though to just take me through their thought process at the very least for how they solve this problem. Kimura, would you be able to come off mute and share just how you kind of attempted the problem, if you, or answer if you were able to arrive? Would you be able to come off mute? Steve, are you there right now? Okay, how about Rude Charles?
What I tried to do, I don't know if it's right. I just plugged in one for both. And I don't know if that's the correct method to use, but when I plugged in one for both, for the top one, I got 9, which is x, well, basically 9, and for the bottom one, I got 9 as well. So I was like, it could be continuous, but the problem would be like the thing that was bothering me was the fact that it says x is not equal to 1, so I don't know if that would be correct.
Gotcha. Yeah. So I think the domain is probably the confusing part. But could you clarify what you mean by plug in for both?
Plug in,
both of what?
One into all the x's.
One into, okay, gotcha. So, okay, I'm gonna write this out and then ask you a few more questions. Okay, so I think I'm gonna start again by just writing out the formal definition. The limit as f of x as x approaches 1 is equal to f of 1, right? So again, if this is correct, then it is continuous. Now, expanding upon this, the limit as x approaches 1 from the left of f of x, if it's equal to the limit as x approaches 1 from the right of f of x, that would be equal to f of 1. So, Ruchar, would you be able to clarify? So, from the left, which function would you plug 1 into?
X squared plus 3x plus 5, because it's not equal to 1.
Yep, that's exactly right. So, from the left, we're going to plug it into this function. So, it's going to be 1 squared plus 3 times 1, so equal to 5. And then how about from the right?
The same thing, basically.
Yep, that's exactly right. So 1 squared plus 3 plus 5. And then how about f of 1?
6x plus 3.
Yep, awesome. So 6 times 1 is 1 plus 3. So basically what's going on here is we have like a function where at every point but 1, So let's say at every point but 1, it's this function. And again, I don't know what this function looks like, but there's a hole at 1, right? And then at 1, only at this one point, it's defined by 6x plus 3. So I'm not sure exactly where that might be. It might be right here, it might be right here, but it's basically at that one point. Now we're going to evaluate this. So from the left, we're looking here. From the right, we're approaching here. Again, it's the same function. It's x squared plus 3x plus 5. So it's kind of expected that they'd be equal to each other. But it's going to be 1 plus 3 plus 5 is equal to 9. It's equal to 1 squared plus 3 plus 5 is also equal to 9. And then 6 plus 3 is also equal to 9. So, well, that kind of answers our question. So all three of these are equal to each other. So we're going to have a continuous function. The limit as x approaches 1 of f of x is equal to f of 1 works. It is continuous. Okay, awesome. So there's only like 1 minute left in class. I'm gonna leave this up for everyone to copy down, and then I will scroll back up to the first notes if you want to stay after class to copy that. And then also I'm gonna post the notes after class. Besides that, same stuff. Turn in your exit ticket by 10 p.m., turn in a picture of your class notes by 10 p.m. And then please start working on your packet if you haven't yet. It honestly should not take that long. And I do have the YouTube video up. So yes, consult that. The YouTube video was sent. You can see it in the email I sent yesterday or in the Google Classroom topic. But yeah. And I can stay a few minutes after class if you have people have questions. But thank you everyone for coming. Thanks, Kayla. Have a good day.
Oh, there's no way.
Yeah, go for it.
We turn in the do now too.
Could you, are you asking if?
Turn in do now too.
Yeah, if you weren't able to turn it in for whatever reason, like if you couldn't take a picture or something, it's not the biggest deal. But if you are able to, I would like for you to turn in the do now. Okay, hopefully everyone has this copied down. I'm gonna scroll up here in case, I forget who asked for this part. I'm gonna leave this up for like 30 seconds and then scroll back down. Thanks, Favor, have a good day. So yeah, if you need to copy down, and remember also, I'm gonna post the annotated notes like maybe an hour or two after class. So yeah, you should have the notes available to you.
Can you go back, please?
Oh yeah, so you want to go back up again? Here?
Yeah, thanks. Just like 5.
Okay.